Hello, everybody. This is the start of distance learning. So I hope you're as excited as I am. Keep in mind, you guys, we're going to do the best we can do together. This is something new for both you and for me. So I will do my best. Make sure you communicate, email as needed, and we'll make it through together. So I'm just going to review what we did on our last day of notes together just to make sure everybody's on the same page. And we are going to use the same packet that I handed out at school. So 8.1, adding and subtracting polynomials. How do we manipulate polynomials by addition and subtraction? So we're going to fill in a polynomial. It's 8x to the third plus 6x squared minus 5x minus 10. And remember, poly means many, and nomial means terms. So obviously this has many terms. There's actually 4 in this one. All right. And it's an expression having terms that have non-negative exponents. Standard form, what does it mean to be in standard form? Your example's in standard form. It means it has to have exponents written in descending order. So we have a third power, second power, this is a first power, and technically this is an x to the 0 power, which is just 1. So we don't have to bother to write it. You will want to write all of your answers in standard form. The degree of a polynomial, we have to have some common terminology here. It's the value of the highest exponent. So in our example, we have 8x to the third. So this polynomial up here would be considered a third degree polynomial. Or if we look at our chart, a monomial has 1 term. Binomial has 2 terms, and there's your example. Bi means 2. We are bipeds. We walk on 2 legs. Quadrupeds walk on 4 legs, like Fiona. 3 terms is called a trinomial, and we've got 3 terms here, 6x squared, minus 5x, and a 10. And then anything that's above, it's 4 or more terms, we just call it a polynomial. And our example is, in fact, a polynomial. Now that's based on the number of terms. That's how we name it, on the number of terms. The degree name that we can connect with these is if you just have a plain number, a constant, doesn't change. That's what constant means, doesn't change. Then it has a degree of 0. We call it a constant. A first degree is linear, so y equals mx plus b, anything that has that form, and it's only to the first power. That is something that we can graph on a coordinate plane. It's called linear. Quadratic, we've talked about those. Quadratics are going to be U-shaped graphs. So 6x squared plus 7 is considered a quadratic. And if we look back up here, that would be a binomial because there's only 2 terms. This is a linear monomial because there's only 1 term. Cubic is a third degree. So that means your highest power is 3. And this happens to be a cubic trinomial because there's 3 terms, 1, 2, 3. Quartic, we do have a name for 4th degree, quartic. So 3x to the 4th plus 2 is an example. If I were to name this based on its degree and on number of terms, I would call this a quartic binomial because there are only 2 terms. All right. So here's a funny math joke, hopefully you can appreciate. 100th degree, what is a 100th degree polynomial called? A hectic. Ah, just kidding. It is technically called hectic. So, okay, moving on. So, adding polynomials. Remember, when you add terms, you have to have the same degree and the same variable. So, same letter, same power. So, if you look at this example here, we've got 2 polynomials being added. They're encased in parentheses. And I am going to look for something else that has an x to the third. Nothing else in here has an x to the third. So, that gets to stay by itself. However, if I look at this, 9x squared and 8x squared, be careful, take the negative with the 9. I can add those 2 together, and if I'm down 9 and get 8 back, Then I only have a negative x squared left. Highlighters might be nice. I did shapes like this to collect my like terms. But a highlighter might work too. Some of you I know have been using those in class. So choose what works for you. So I just combined the negative 9x squared and the positive 8x squared. Same letter, same degree. I can put them together. All right, then I'm going to look for anything that's just a plain x. I've got a negative 2x here. And I don't see, oh, here's another x right here. So 1 plus negative 2 is a negative 1, and x just stays as is. Ooh, why do we not have a focus? Okay. Sorry about that. And then we have a 2 and a 4, and those we can just add together. Be careful. Make sure that you take the operation with the terms. So for example, up here, I rewrote things and I made this negative 8x to the third plus x plus a negative 9x squared plus 2. And some of you can do, combine these things by just taking that operation with the term that follows it. Some of you, it might be helpful to rewrite it as an addition problem, and then you won't lose those positives and negatives and avoid silly mistakes. So in this one, again, we've got a subtraction sign. Remember when you subtract, I'm subtracting this whole number, so I have to distribute that minus sign to every single term behind it. So what is that going to do? I'm going to get negative 6x to the fourth plus 5x plus a negative 3. I added the opposite. Plus, add the opposite. I'm going to make that a negative 2x to the fourth. Add the opposite. I'm going to make that a plus negative 4x squared. Add the opposite. Again, it becomes a plus positive 3x. And add the opposite. It becomes plus 3. Now I'm going to look and combine my like terms. I have two terms that have an x to the fourth. So negative 6 plus negative 2 is negative 8x to the fourth. I have an 1x squared term. That goes next because we want to do it in standard form, which is a minus 4x squared. I have two just plain old x terms, so 5x plus 3x makes 8x. And I have one constant, negative 3 and positive 3. When I add those together, they actually go away. So in the end, negative 8x to the fourth minus 4x squared plus 8x. So make sure to distribute that subtraction sign. And I like to use the arrows to make sure I don't leave anybody out when I do it. All right, so business revenue and business expenses, and then profit or loss. That is our next situation here. So you probably need to know that business revenue is the money that you take in when people buy items from your business. Business expenses are all the bills that you have to pay. So that's, paying your employees, paying your lights bill, buying your product, paying for advertising, etc., etc. A net profit would be the money that you make after you have taken your expenses out, and a loss would be that your expenses cost you more than I'm recording right now. Your expenses cost you more than the money that you brought in. So we'll set it up. I've got a 2x squared plus 120x minus, I'm going to take away my expenses, which is this polynomial. Again, I'm distributing the negative. And I'm going to combine my like terms. 2x squared plus a 0.5x squared is 2.5x squared. I've got two plain old x terms, so 120 plus 300 makes 420. And I've got an 8,000, and there's no other constants. So my expression will be 2.5x squared plus 420x plus 8,000. By the way, we would call this a quadratic because it's second degree, trinomial because there's 3 terms. Okay, looking at the next one, again, I'm going to distribute the negative sign. And then I'm going to take my result and combine my like terms. I notice that negative 8x squared plus 8x squared goes away. So I don't have to worry about that. Looking at my x terms, I just have a 12x and a 3x, which is 15x's. And my constants are a 6 and a negative 4, which is 2. So 15x plus 2 is what we get as a result. All right, to wrap it up, when you add or subtract polynomials, both the variable, which is the letter, and the degree, which is the exponent, have to match in order for you to put them together. And then remember, distribute subtraction signs to all the terms in the parentheses that follow it. All right, hope this was helpful. We'll see you tomorrow.